Okay, so in this video we're going to be discussing the Argand diagram. Okay, it's a follow-on from the first couple of videos that were based on complex numbers. So, first of all, I just want you to look at this diagram here. Now, it looks very familiar. It looks like the XY plane that we would have had before, the Cartesian plane. So if you were to plot the point, say 2, 4, you'd go across 2 and you go up to 4, and that's your point on the XY graph. But because we're talking about complex numbers, we mention real and imaginary. Now, you can also plot the real and imaginary numbers. So, on the right hand side here, I have four complex numbers, Z1, Z2, Z3 and Z4. And I'm going to put these points onto this Argand diagram. Okay, it's just called the Argand diagram. So, you have an XY plane or a Cartesian plane are the same thing. And then you have the Argand diagram if it's complex numbers. So, the first thing I'm going to do is label my axis. Now, in coordinate geometry, this was going to be the X and that was going to be the Y. And anytime you had a point, the X came first and then the Y. Now, with complex numbers, it's almost identical. You have a real number and you have an imaginary number on the same complex number. It's the same concept here. The X-axis, as you would know it, is the real axis on the Argand diagram. So I'll put in RE for real. And the y-axis is the imaginary. Okay, so the x that you would know is the real and the y is the imaginary. So now I'm going to plot these points. So 2 plus 3i. 2 on the real axis is here. Plus 3i means I go up 3 slots to here. So that's my first point. So that I'm going to call Z1. The second one, Z2, minus 4 minus 2i, so go back, minus 4, 1, 2, 3, 4, and then minus 2i means I go down 1, 2, so that's this point here. So that point is Z2. The third one, 1 minus 3i, 1 minus 3i, so that one is Z3. And the last one, 0 plus I. Now, 0 real is the same as if the X was real. If the X was real, it would stay on the Y-axis. Sorry, if the X was 0, it would be on the Y-axis. Because the real is 0, it's on the imaginary axis. So 0 plus I stays here, because you don't go left or right. It's 0 on the real. And it's plus I on the imaginary, so it's this point up here. And that one is Z4. So now another word that is commonly mentioned with the Argand diagram and when you're plotting complex numbers is the modulus. Now that's very, very important. Okay, the modulus is the distance from the point you're talking about, so I'll take Z1, the point you're talking about back to the origin. So if I get my ruler, put my point on Z1, line it up with the origin, and strike it back, that is my modulus. Okay, it's also kind of known as the radius. Now I'll explain in another couple of seconds where that comes from. Okay, so anytime you're asked for the modulus, it's the point back to the origin. So this one would be from that point back to here. This one is this point back to the origin. And this one on the axis, even though it's not in the normal space, it's on the axis, but it still goes back to the origin. Now you can't see it because the axis is covering it, but it's still there. Okay? Now, another point that usually comes up, I think this is one of the best ways, or one of the easiest ways I think it is to explain what complex numbers are. If you had, say, a video game, and you wanted your character to go from here to, we'll say, this point here. So you go across 1, 2, 3, 4, and you go up 1, 2, 3. Your character would have to go across and then up, if we were talking about the XY. If they want to get to this point, you would go across and down. This point is okay, it's just straight up, and this point you'd go across and down. Now, in most of the modern video games, characters don't work on the XY axis. They don't go across, up like this. They actually turn. So if I want to get to this point up here, this imaginary point, I start at 0, 0 at this point here. I turn to where I want to go. So now I'm pointing this direction, and then I go that direction. Okay, if I want to get to this point, again, I'm going to be starting pointing to the right. I'm going to turn on the point, so I'm opening up an angle to get to in line where I want to go, and then I go forward. If you're thinking of a video game and you want to shoot somebody that is standing on one side, or if you're aiming a gun in a game to turn to a certain direction, you don't want to go forward and across and forward and across and forward and across, because that wouldn't work. So what you would do is turn and then shoot. Or if you're trying to pass a ball in a game, you turn to the person you're passing to and then pass it. You don't go like this. So this is very, very important with all types of video games, all types of animation. If you can think of any animated TV show, the character doesn't walk across the screen like this. They turn, so they start in one position, they turn, and then they go forward. Okay? Now, how far they go is our modulus. Now, what we're going to try and work out is how do you actually find the modulus. So how do I get to this point? I'm starting in the origin. I want to get to here. I find the right angle, which we'll talk about in another video. I find the right angle, but I want to go a certain distance. How do I know when to stop at that point? And if I take another colour and I draw this line, I've now got a right angle triangle. Right angle triangle, Pythagoras theorem. Pythagoras theorem is very important. So this is going to be my 90 degrees. This is my opposite. This is my adjacent. This line is my hypotenuse. So the modulus is just the distance of Z1. So Z1 squared equals my opposite. How tall is that? So it's 1, 2, 3, because it's 3 from here. So it's 3 squared plus, how far across did I go? 1, 2, 2 squared. Okay, and now I want the modulus of Z1. So to get rid of the square, I need the square root. So the modulus of Z1 is the square root of 3 squared plus 2 squared. Sorry, I jumped the gun a small bit. Which is the square root of 9 plus 4, which is what I almost wrote down, which is the square root of 13. So this line is square root 13 units long. So that is my modulus. Okay, that is how you find the modulus of any complex number when they're given in this form. Okay, so that's just a quick introduction on the Argand diagram and what it is. Just a quick recap on it. 2 plus 3i. The real is the x-axis that you know. The imaginary is the y-axis that you would have known before. Plot your point, and that's your point plotted. That's grand. If you're looking for the modulus, you join the point back to the origin, and then you've created a right angle triangle. Use Pythagoras theorem, and that will give you the distance from the origin to the point. That's how far, in a video game context, in animation, that's how far your character is going to walk within the show. Okay, so in the next video I'll expand a little bit more on the Argand diagram, and I will introduce the angle, because that's also very, very important.